Bismillahirrahmanirrahim. Assalamu alaikum and a very good morning to all of you. I'm Amjad Ali here from Doha, Qatar. Last time we were talking about atomic structure topic. It is the chapter number 2 in 11 grade chemistry. Today we are going to discuss the quantum numbers. So first of all, what are quantum numbers? Quantum numbers are the sets of numerical values which give well-behaved solutions of Schrodinger wave equation. You remember in my last lecture, I told you about the Schrodinger wave equation. When Schrodinger wave equation solved, so different numerical values obtained, and those set of the numerical values are called quantum number. Now, quantum numbers are of four types: principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Now, one by one, we discuss these four types of quantum number. First of all, as regard of the principal quantum number concept was already given by the Bohr. So, what is its role? Its function or its role is this quantum number help us to find the distance of electron from the nucleus. So I mean with the help of principal quantum number, we can find the radius of an orbit. So it can be represented with n, and its value can be any non-zero number. Now for example, if the value of principal quantum number n is 1, so it represents first shell, first energy level, first shell, that is K shell, and maximum electron in K shell can accommodate 2. Same, if for example the value of the principal quantum number n is 2, it represents second energy level. Second energy level mean L shell, and L shell can accommodate maximum 8 electron. And if its value is 3, it will represent third energy level. Third energy level is M shell, so it can accommodate maximum 18 electron. And same, if the value is 4, it will represent N shell, and N shell can accommodate maximum 32 electrons. We can also calculate these maximum number of electron with the help of a formula, that is 2n square. By putting the value of n, we can calculate maximum number of electron in any shell. So it is the first quantum number, principal quantum number. Now second quantum number is azimuthal quantum number. Azimuthal quantum number is actually giving the answer of Bohr defects. In Bohr, there was one defect when the spectral lines observed with the powerful spectrophotometer, so it splits up further. So answer of that is given by the azimuthal quantum number. What is its function? Azimuthal quantum number tells us about the shape of orbitals. So here this one is explaining about orbital. Orbitals are S, P, D and F. So these are four orbitals. Azimuthal quantum number is represented with small l letter, and its value can be 0, 1, 2, 3, so on. So its value will depends on the value of n, and n minus 1 can be the value of l. Like for example, if the value of l is 0, so it will represent s. So if s subshell orbital, value of L will be 0, and S, it can accommodate maximum 2 electron. If for example the value of L is 1, it represents the p orbital, and p orbital can accommodate maximum 6 electron. If the value of 2, it represents the d orbital, and it can accommodate maximum 10 electron. If value of L is 3, it represents the f orbital, and it can accommodate maximum 14 electron. So it's about the azimuthal quantum number. Azimuthal quantum number give us the idea about the orbitals. And here there are the four types of orbitals. S, S is for short, P for principal, D for diffuse, and F for fundamental. Anyhow, these are the four atomic orbitals. Next quantum number is a magnetic quantum number. Magnetic quantum number give the answer of another defect of Bohr atomic model. In Bohr, there was one defect. Bohr cannot explain the Zeeman effect and Stark's effect. When electric field or magnetic field are applied on the spectral lines, that are further divided into finely divided lines. So answer of this one is, actually these orbitals are of more types. Yani P again of 3 types, D again of 5 types, F again of 7 types. Anyhow, the magnetic quantum number tell us the orientation of orbital in the space. It is represented with M, and its value depends on the value of L. So for example, its value can be 0, +1, -1, +2 and -2. If for example, if the value of the L is 0, the value of M will also be 0. Look at here. For example, if the value of L 0, value of M will also be 0. It represents the S subshell. S subshell, it has no orientations. So it is only of one type. S is only of one type. So this is the reason Bohr performed whole of his research on hydrogen atom, and hydrogen atom has just one electron. So one electron accommodate in S orbitals. So due to that, these defects were not observed as regard of the monoelectronic system. For example, if the value of for the p orbital, the value of the m, it will be 3, like 0, +1 and -1. So these three value mean p orbital, it has the three spaces orientation. So p can be of the three types: px, py and pz. And if for example, if the value of m for the d, it will be 1, 2, 3, 4 and 5, 0, +1, +2, -1, -2. So 5 values of the m will be for the d orbitals. It means d orbital is of 5 types, and it can accommodate maximum in total 10 electron, and each will have maximum 2 electron. And as regard of the f atomic orbital, the value of the m, it will be like 0, +1, +2, +3, 0, -1, -2, -3. And in total, there are the 7 values. 7 values mean the f has 7 space orientation on the space, and it can be of the 7 types. Each will have the 2 electron, and in total 14 electrons can accommodate in f orbital. Last quantum number, yani quantum number 4, that is a spin quantum number. Spin quantum number, it is represented with S. What is its function? It helps us to describe the direction of spin of electron. According to this one, for example, in any orbital, if more than one electrons are there, half of them will move clockwise and half of them will move anti-clockwise. So it's not possible if more than one electrons are in one orbital and they move in with the same spin. It's not possible. Half will be clockwise and other half will be anti-clockwise. Dear students, I explain you today the quantum numbers and types of quantum number. So inshallah next we will discuss the another lecture. So take care of you and take care of the people around you, and keep watching my channel to study the different lectures of the chemistry. Okay, Allah Hafiz.